Well, it looks like we can start. Welcome back, everyone. We're going to finish off week 6 by working through our unit 3D. This is going to be the last unit for chapter 3 and beginning to work in our new chapter 4. So we're finally turning the chapter to a new one. As far as the announcements goes, I don't have too much other than our quiz 4 is based off unit 3D, will be due tomorrow. And a brand new quiz is posted, which is going to be based off unit 4A. But welcome back. I hope you all had an awesome President's Day. Looks like for as far as the schedule goes going forward, we don't have too much going on. It's going to be class as normal, working through chapter 4 in the coming weeks. We also have midterm week coming up, but we don't have any special assignment or special project or exam or anything like that for midterms. Pretty much what I'm going to do for midterms is your grade as it stands on Friday of that week there just becomes your midterm grade that I'll upload to the MyISU system. And as we discussed, we'll be getting closer and closer to exam 2 once we're around midterm week. So I'll be posting on this weekend here the exam 2 information. But at the moment, looks like we are pretty much doing class as normal, finishing off the unit and starting a brand new one. But any questions or comments at all, folks, to start us out today?
I did have a question on the MyLab homework. And just if
Yeah.
we have time, I was wondering if we could go over it. But it is question number 8 of 3C. It is two problems in parentheses times two scientific notion problems times each other, written out in 3 significant digits. I was just hoping we could go over that because I had to play around in Desmos with it a little bit to get it.
Okay, let's take a look at that. And that'd be a good review of significant digits in the first place. So yeah, that'd be a great suggestion to start us out today. Thanks for asking about that. So let me open this up. Get kind of a mental break as I click through all these things. And let me go to course home. There we go. Took me a minute to recall. View student home and just about there. So this was unit 3B, I think, or was it 3C?
Question 8 of 3C. Yeah.
Gotcha. So let me click on there. Question number 8. Okay, mine's probably a little bit different, but it should be kind of similar in spirit when we get through this one. Does this look about right for kind of different numbers, but the same kind of question?
Yep.
Awesome. So it says carry out indicated operations, give your answer with the specified number of significant digits. So yeah, we have 2 multiplications we're doing, scientific notation, and we want to capture 3 significant digits altogether. So let's give this a try. To start out, in doing this multiplication indicated above, I probably would begin by just going like this. Take the 1.86, multiply it by the 7.1, and then beyond that, organize the scientific notation part. Then it's times 10 power 3 times 10 power negative 2. So on the side, we can say 10 power 3 times 10 power negative 2. The exponents that we have here are going to add up. So this will just become 10 to the power of 1 altogether, or just 10. So we can make a substitution for that on this part right here. And for the next, I'm going to need a calculator for sure. So where's my calculator? There it is. Next, we have 1.86 times 7.1 altogether. We're going for 3 significant digits. I'll carry in exactly what we have at the moment, put it back into scientific notation, and go for the 3 significant digits. So let me keep this exact number as we have, 13.206. So hang on, let me get that going. Annotate is sometimes kind of a pain. There we go. Equals 13.806. And wrong color. Let me try to keep that color the same. 13.806, and I think I need to double check my number at that point. 206. Yeah, I knew I lost a digit somewhere. 13.206. Then this will finally be multiplied by times 10, just 10 itself, 10 power 1. Now, next issue, I think I recall making this mistake a couple times in class, is the number kind of looks like it's in scientific notation, but it's not quite there, right? The number has to be specifically between 1 and 10. So we're exceeding it on 13. We now need to do a decimal shift to get it in the right range. So on the next step, that's kind of weird, the dot turned blue. On the next step, we can rewrite 13.206 in this way. Go, once I get the color right, the 13.206, I want to shift the decimal one spot to the left. So now it's 1.3206, 1.3206. It'll be times, we made it smaller by a factor of 10, so we'll include just a times 10. That's what would rewind it backwards, but we'll leave it just like that for the sake of scientific notation. Times 10 again. And then now we've got a 1.3206 times. From here to here, we have just 10 times 10, so 10 power 2. And we're nearly there. 1.3206 times 10 power 2 gets us about where we want to go. We just need to do this part, 3 significant digits. So rounding to 3 significant digits, we'll read from the right to the left, keeping just these 3 digits so far. But any questions at the moment, getting just to this stage?
No, it was just the 3 significant digits that confused me.
Gotcha. So yeah, we'll keep it just those 3 digits right there for the significant digits part. And that means my claim is the answer is 1.32 times 10 to the power 2. And the way I did it on paper here is kind of just playing around with the 10 to the power stuff. Another way to go, maybe slightly trickier to put in the calculator, but it does work. This is something you could do in an exam situation, is put in 1.86 times 10 power 3, multiply that by 7.1 times 10 power negative 2. Then we get to 13206. That means it has to shift left 2 places. And that explains why the 10 power 2. But let's see how this goes. Let's see if we get exactly the right answer. 1.32 is my claim, times, what if I can put a dot? Probably not. I bet you they're going to require that times there. 10 to the power 2. So let's hope for the best. Any questions or comments before we punch this in? Okay, so to enter, and that got us through that one. Well, thanks for asking about this one. I think this is a good one to just throw in on our actual significance digits notes. This was in unit, let's see, 3C. So I'll re-upload the 3C notes with this question as well included. And it goes pretty well with the significance digits. Oh, hang on, let me make sure everything kind of plays nicely with the windows. It goes pretty well with the significant digits table. There we go. So I'll drop it, say, right about here. I think that's a good spot. Again, thanks for asking about that one. These are always great questions to kind of review, start out class with. Other questions or comments at the moment, folks, before we get started today? Okay, well, so far with what we have going on, once I get my windows back in order, let me put this back over here. Oh, that actually doesn't come back too nicely. Now, if I back up enough, I probably can get the original comment back, but there wasn't too many comments on here anyways. Well, with where we're at so far, we're about to finish off Unit 3D and then move to the next chapter. So let's take a look into where we left off before going on holiday. we were here. There was a lot going on in this section, dealing with the consumer price index just as a concept, and then finally the federal minimum wage table. That's the table that we're looking at right here to get us started. But just for kind of a refresher on what's going on with this unit altogether, the average annual consumer price index was the major table that we're working on. This section's called index numbers, the consumer price index, and beyond. And this part is just the beyond applications to all these ideas. So as far as what's going on with this table, everything you see here for the CPI is really just a percent. So if we focus on year 2011 with the consumer price index 224.9, really all we're saying is that the average cost of goods and services is 224% between these base years from 1982 to 1984, where the table is normalized to 100%, averaging those consumer price indexes. So we can see that this is the basic computation that the federal government does on a monthly basis and then uses to compute inflationary rates. At the same time, we have the federal minimum wage table. This isn't the whole story about what's going on in the economy for Americans. Seeing what's going on with the federal minimum wage table also puts the consumer price index table into context at the same time. And so the refresher on this table is we have actual dollars, the actual minimum wage set federally across the years and decades, and the inflation adjusted dollars for 2020. So that means, oh, sorry for that. That means if we look at, say, any random row here, maybe 1967, the minimum wage was $1.40 per hour. But if we adjust that for inflation, that comes up to $10.82 in 2020 dollars, not quite 2026. How do they adjust for inflation? Well, they are really just using the consumer price index table. So that's what's going on with the table so far. That's what makes this section kind of challenging, all the dense informational tables that we see here. Any questions at the moment, just looking at either of those two tables? Okay, the other big idea in this section was really this formula. You might have noticed that it's been screenshotted into a lot of problems as we went through the notes. Some of these computations are kind of confusing on exactly why you put one number in one spot, another number in a different spot. But if you think in terms of this formula right here, they're really organized pretty close to all of the questions on these notes. So the refresh on example 6 was, where you're using the minimum wage table, we can express what a dollar was worth in 1945 in terms of 2020 dollars, because this table is giving us the fact that 40 cents is equivalent to $5.76. Sure, this was a minimum wage, but it's also a nice and fast conversion. What we did was we took a dollar in 1945 money, multiply it by the rate, dollars in 2025 money, sorry, divide by dollars in 1945 money. We grab the 576 to put in place of the numerator here, 40 cents in the denominator. And we found that $1 in 1945 is worth $14.40 in terms of 2020 dollars. So that was this formula here in action. We're going to use it one more time for our very last example. But any questions at all, folks, with this big refresher? Okay, the next example I think is kind of strange in a certain sense. There's a big punchline to example 7, but let's look at what we did. It said use the average consumer price index table to convert the 1990 minimum wage from actual dollars to 2020 dollars. We know that the 1990 minimum wage by this table was $3.50, and it's already converted in 2020 dollars to $6.94. But we're asked to do this in a different way. It said use the consumer price index table computation. So we use this formula once again, following the same color coding, pulled up the consumer price index table. And the idea with this computation was we looked up consumer price index in 2020, it was 258.8. Divide by consumer price index in 1990, that was 130.7. And we got the minimum wage in terms of 2020 dollars following this formula was $6.93 per hour. Part B is asking, is this consistent? And we said yes, because if we look at the federal minimum wage table, we're only off by a cent, and that was likely due to rounding. But really the whole idea with example 7 is this table here itself is built off the consumer price index computation, that index table we are looking at. And so we can either do computations through the federal minimum wage table or do computations through the consumer price index table, depending on what the question is. So that was the refresher so far on example 7. Next, we're going to turn into the brand new question. Example 7 is just telling us we're allowed to use consumer price index to come up with federal minimum wages. And that's what example 8 is all about. Let's put this one on a new page. And just because it's been a handy formula, let's drop this in one more time and see where we might have to use it for our last problem. The question goes on by saying, how high would the minimum wage need to have been in 2025 to match the 1956 inflation-adjusted value shown in the minimum wage table? So we need to bring up that federal minimum wage table to get started. Let me pull that up here. Pretty much just using this trick with a separate window so we don't have to scroll up and down a whole bunch. But I do have to scroll on this, so there's a trade-off here. So here's the federal minimum wage table. The 1956 inflation-adjusted value shown here is $9.49. But that's in 2020 dollars. This is asking, what should it be in 2025 dollars? So that's the new computation. But let's start off by just putting in this value. 1956, inflation adjusted to 2020 dollars is $9.49. So let's write that in as the 1956 inflation adjusted minimum wage is, and I forgot the value already, let me pull that up, $9.49. But we should add one extra qualifier, that $9.49 is in 2020 dollars. The question is about, what does it need to be in 2025 dollars? So that's where our computation is going to begin. It uses this right here, but this thing is going to play the role of blue in our formula down below. We're doing a price adjustment through inflation. We're going to use this consumer price index table. The thing that's going to be in green is the amount in 2025 dollars. So let's start off by just stating this formula verbally, matching the context we have. The 1956 minimum wage in 2025 dollars, so that's what we want to calculate, is going to be equal to, we take the value that we had in the table. Hang on, let me go to that table just to emphasize. The value we had in the table was 1956, $1. This has been already inflation adjusted to 949, so we'll place that on the paper here. And the reason we have to use this table is because our consumer price index table didn't go all the way back to 1956, so we actually needed to use this value right here. So I can't find a consumer price index for the dollar in 1956. So we just jump forward into the future for 2020, that figure there. So let's put in 1956 minimum wage. This is inflation adjusted. To the 2020 dollars. So we have the thing in blue, that's what's going to go right here. The rest of the formula is just going to be the consumer price indexes. We'll say times consumer price index for the thing that came first, 2025 year. So CPI 2025. Then we divide it by the thing that came second, this consumer price index in 2020. So CPI 2020. And this is the structure of our formula, how we're going to use it. This is a pretty big step in the middle, I have to admit. There's lots of writing, but if you find that it's helpful, it's a good thing to get in the habit of doing. If you leave off this step and you know exactly what CPI values you're going to plug in, then that's okay. You wouldn't be docked points for that. But as it stands, any questions with the formula that we have so far? Okay, well, here's the fun part. Let's drop in those values. Inflation adjusted minimum wage to 2020 was the $9.49 from 1956, then multiply it by consumer price index table is what we're going to need next. Just finding a spot to put this. That should fit about there. So for 2025, oh, that's the wrong table. Let me scroll back up. For 2025, it's going to be 321.9. So that's our numerator. Then divide by the year 2020. Consumer price index in 2020, went a little too far there, is 258.8. So 258.8 here. Now we just need to crank this out in the calculator. So after we get our figures in, here's my calculator. I've got too many windows open, it looks like. Take 949 times the fraction, 321.9 over 258.8. And because it's money, we'll round it to the nearest cent and say $11.80 per hour. So finally, the summary to this is if we adjust the minimum wage, inflation adjust it from 1956 to the year 2025, people in 1956 were getting an equivalent $11.80 per hour. Well, we did, folks. That's the last question of the notes. Any questions or comments getting through that final computation here? Okay. Well, as far as this question, these kind of questions might go in an exam setting, notice that this formula was the major superstar, just putting everything together. You'll know there's going to be a fraction somewhere, but this formula was really valuable, making sure you had the right index in the numerator, the right index in the denominator. Beyond that, anything like this will definitely be provided on the exam. If we're going to almost assuredly going to have the consumer price index table on the very last page of the exam, or maybe I'll bring it right into the problem, just like on the very top, and then the exercise will be right below. So it's right there in front of us. We won't have to flip pages. And the same idea, if we are going to involve the federal minimum wage table, this will be on the exam as well. So don't worry about trying to copy all this information onto the notes. That wouldn't be the best use of the real estate for the lecture notes the exam notes you could bring to exam two. But so far, that's a kind of interesting story that's being told when you look at the consumer price index to allow us to do inflation adjustments from one year to the next. In 1945, or excuse me, this was 1956, minimum wage inflation adjusted to 2020 was 9.49. If we inflation adjusted it to 2025, we just found it's 11.80 per hour. If we look at the actual dollars in 2025, it's still sitting at 7.25 federally. So it's kind of an interesting, strange values we're seeing here. In fact, the best year ever was 1968 if we inflation adjust to 2020. And then these values just start to drop as you go throughout the years. Sometimes it backtracks up and down a little bit, but it's been on a downward trend. We can only really see that when we're using the consumer price index, inflation adjust things. That's the value in these kind of computations. But for the moment, we are now done with chapter 3. We're turning this over to chapter 4, doing some financial mathematics. Any last final questions or thoughts, folks, before we move on to chapter 4? Okay, I'll get this saved up later and the PDF uploaded. And this is exciting. We're now moving over to chapter 4, managing money. There's kind of a lot going on in chapter 4, and the Unit 4A objective, well, through the title, the objective of applying, taking control of your finances, is a really, really humongous topic. So we're not going to try to cover every aspect of taking firm control of your finances, but we'll look into several themes. First theme will be about controlling finances. The next theme will be about making a budget, the step-by-step process. And then finally, the next theme is going to be looking into making decisions based off an analysis of several factors. For example, in example 8, we're looking at if taking something in state versus out of state is better. Example 9, we're going to look at if we should buy a new car for driving an old truck that gets 9 miles per gallon, but keeping in mind that the new car, its price tag plus the interest is going to cost us $59,418 over the course of 5 years. We'll decide if it's better to keep driving the old truck or buying the new car. So there's going to be decision-making kind of processes in the middle. And the final thing we'll look into in Unit 4A is insurance costs, issues with premiums, deductibles, and co-payments as it relates to auto insurance, and the trickier concept as it relates to health insurance as well. So it's actually a really humongous unit. There's lots of things to get into. My goal in the syllabus was to get this done in 2 days, but if we need to take an extra time when we come back on Monday to finish this off, we'll definitely do so. I don't think this is a good one to try to race through. So here's the landscape of what we're doing so far in this section. I'll take a screenshot of this theme right here, controlling finances. We'll highlight which area of this that we're really working as we go from problem to problem. Well, first we might as well read Controlling Your Finances. The advice that the author gives for this aspect of personal finance, which is, again, a humongous topic, is know your bank balance. And that's trickier than it might seem because, bank balances have things that are pending items. You might have things that are coming out as automatic payments and so on. So really knowing your bank balance is a big subject in and of itself. They say avoid bouncing a check. That's kind of the major issue with knowing your bank balance or having your debit card rejected. By the way, overdraft fees for bounced checks is $1 billion industry in the United States of America. So this is a really big area to watch out for. People are making billions of dollars on this. We're going to focus a little bit more on this. Know what you spend. This is going to be the major thing that we're looking into in the next 3 examples. We're going to say keep track of your debit, credit card spending as part of it. But we're going to look into what are costs really in terms of monthly costs, weekly costs, or yearly costs on the next examples. Then the author, just to fill out the topic, says do not buy on impulse, make a budget, don't overspend it, is the whole theme for controlling your finances. We're going to be more focused on the questions in my lab, the questions we'll do in these notes on point 2, knowing exactly what you're spending on a monthly basis for certain expenses. Well, any questions at all, folks, with the topic here at the moment? Okay, I would say the first couple examples, they're kind of nice questions. They go kind of quickly, they're nice warm-up problems, but the computations just kind of slowly build as we go. So we might as well start strong. We're gonna kind of hit this one really hard, even though it's kind of a fast problem. We'll do a serious workup on every single one of these. It says to start out, suppose that you spend $22 every week on various digital streaming subscriptions. Maybe it's something like Netflix combination with maybe Roku services, and $185 per month on dining out at restaurants. What we want to do here in the theme of knowing what you spend, compute the total cost per year for these expenses. And it says, assume that there are 52 weeks in a year. That's kind of a weird assumption to make, right? But we'll see later on the notes why I'm saying that here, just being really specific. This language is also repeated in my lab, so I felt like it was a good thing to include here. So to start off, if we want to find the total cost for just these two expenses per year, we need to take the $22 every week on digital streaming services and do a conversion of that into a per year amount. So we'll start here. So I'll just say streaming. We'll take the rate, $22. This is every week, so per the 1 week. Our goal is to get this to a yearly cost. And so what this is really becomes really at its heart is a problem from chapter 2, just doing some unit analysis. To get this to a yearly amount, we can use this fact, 52 weeks in a year. So go times 52 weeks per the 1 year. And we're pretty much there. Even though this one didn't look like it was a big deal, we're just taking $22 multiplied by 52. The unit analysis is going to get kind of intense on some of these. And sometimes it's a surprise where you might have thought it's multiplying, but it's actually dividing. The careful unit analysis puts everything in place, pretty much carrying over that skill from chapter 2. But at this point, we're back to the calculator. Take 22 times 52, and it comes out to $1,144. And this is per the year. Then what else do we know? It's $185 per month dining out at restaurants. That was another conversion, but we're just going to go times 12 to get it in terms of years. Any questions with the unit analysis for the streaming side? Okay, so next, for dining out, they say $185 per month. We're probably assuming that that's an average. Maybe some months a little bit under, some months a little bit over, but they're going to estimate that's $185 per month as an average. So let's go $185 per month. 12 months per year, so we can go times 12 months per the 1 year. Our unit analysis says we're on the right track. We're definitely multiplying by 12. And this is now the rate in terms of per the year, 185 times 12. So we get $2,220 per year. And all we want was the total cost on a yearly basis for both expenses. So we're pretty much there. All we need to do is add them together. We can say that the total is, back to the calculator again, 1,144 plus 2,220, $3,364. And that's a pretty decent chunk of change. You could buy a lot of interesting things with that amount of money. You could buy, say, a pretty big TV, speaker, subwoofer system for your living room, or maybe you could buy some computer technology, all sorts of interesting things for that amount of money. But you don't really feel it at the same rate when it's just $22 per week or $185 per month until you're looking at that grand total. Then suddenly it looks like a big chunk of change. Well, that's kind of the theme of what we're doing on the first 3 examples, seeing what you're really spending things on by doing these kind of computations. Any questions at all, folks, getting through this one? Okay, well, let's try out example 2. This one comes into 2 parts, but really it's the same sort of question, just asked slightly differently. It says, compute the total cost per year of the following pair of expenses, so similar kind of scenario. This time we're saying, suppose your monthly gym membership is $65 per month. That seems kind of steep to me, but let's just say that that's the case. And also, you spend $480 per year on routine car maintenance. Again, that's probably, for car maintenance, that's probably less than average. More, maybe someone's taking their car to Jiffy Lube or the other one, what's that called? The one, forget what the other one is in town. I'll just go with Jiffy Lube. And maybe that's just twice per year. You do it every 6 months, and you know that that's your car maintenance. Or maybe it is an average, and sometimes you have to replace, say, the air filter. Sometimes you're replacing windshield wipers. You just looked over the last few years, and that's about where it came out to. So if you know that number, we can now say the total cost per year for the following expenses. But notice that one cost is already in terms of per year, so it's kind of nice. We don't have to do a conversion on that one. We just need to take this $65 and convert it to a yearly basis. That's the theme, just multiply it by 12, but let's put it down on the notes just for a paper trail. We'll say for gym membership, this is at the rate of $65 per month times 12 months for the year. So 65 by 12, wrong window, comes out as $780 altogether. In the theme of knowing what you spend, you might want to do a computation there. If you have, say, extra space in your basement and you saved $780, that might be enough to buy an entire dumbbell set, a bench, something like that. You might decide, hey, I can just cancel my gym membership and start making $700 after the first year for each additional year after by purchasing that set. But now we're combining the gym cost with the routine car maintenance, $480 per year. We can now say the total cost is $780, forgot the unit there, per year, plus $480 per year for car maintenance. So we just about have the total. Just a quick addition here. I need to close that window so I don't keep opening that. There we go. 780. And you close that window as well. Plus 480 comes out to $1,260 per year. So again, not anything too different from what we did on the first example one. And part B just has a fast follow-up question to go along with it. I guess the kind of theme with example 2 is when you're thinking $65 per month, it feels kind of small, but once you relate it to the car maintenance of $480 per year, that feels like the bigger amount. Except over the course of a year, we're being asked do you spend more on gym membership or your car maintenance. It's absolutely the gym membership, by a lot. By $300, we're spending more. That's kind of hidden when we see these numbers just on face value at 65 per month. Relating it back to yearly car maintenance, this seemed like it was kind of small, but it's actually gigantic. That's a lot. So we can say here, for this question, we spend more on gym membership, and then we'll compute by how much. So we'll say here, more is spent on the gym membership by taking a look at this. This is 480, so 780 minus the 480 gives us a difference of $300 altogether. So say by $300. Probably deserves an exclamation mark on that one because it's, again, kind of surprising after we convert this into a yearly basis. Well, that's 2 examples down, pretty much very similar examples. Any questions at all getting through either one of these? Okay. Well, the next one, example 3, my opinion is where it starts to get just a little bit tricky. This one's kind of a weird scenario and a weird name, Vern. I think the textbook comes up with weird names like Vern so that no one feels called out in class. That's a pretty strange name. And we're being told that Vern buys 8 lottery tickets each week at a cost of $3 each. That's small, right? Unless you kind of put it all together, that total might be big. It's hard to tell. Vern also spends $650 per year on textbooks, so Vern's possibly a university student. We're being asked, on an annual basis, the money spent on lottery tickets is what percentage of the money spent on textbooks? So this one is kind of a different sort of question. It's a percent equation, but really it's still along this theme of controlling your finances. We're trying to figure out this part, know what you spend, as we relate one cost, the lottery tickets, to another cost, textbooks. If we're thinking in terms of, say, building a budget, we find that this percentage is quite large. This would be something to eliminate, maybe take out the lottery tickets. Well, let's break down this problem carefully. If we're doing on an annual basis, then we need to take the cost of the lottery tickets, which is at a weekly basis, and convert it to the per year basis. So let's start here. 8 lottery tickets every week at a cost of $3 a piece. So let's say we'll do $3 per ticket. Let's write out this way with a fraction, $3 per ticket. So that's the cost of just a single lottery ticket. But we also purchase 8 lottery tickets every week. So that's another rate we want to throw in there. We can say 8 tickets. And let me fix that part right here. The per is really kind of implied once you put the fraction there. So going fraction already reads as per. If I say per again, that's redundant. That's saying per ticket. So let's throw that out of there. Let me fix that. $3 per ticket is better written like this. And then 8 tickets are purchased each week. So 8 tickets per week. We're converting this to an annual basis, so 1 year, which means we're going back to this assumption, 52 weeks in a year. Go times 52 weeks per the 1 year. And looks like we'll have a cost per year altogether. The U analysis tells us the tickets will cancel out. The week and weeks will cancel out. And that's the cost that we want to see. So that's the unit analysis getting through on this one. At the end of the day, again, it's just going to be 3 times 8 times the 52 weeks in a year. But this is always, I've seen to replicate this comment a lot. This is always a good skill to put down on paper because it is sometimes surprising when something suddenly flips into a denominator and we don't expect it. It isn't always going to be straight multiply through the values we see. But this one was, so we'll take on the calculator, 3 times 8 times 52, and it's $1,248 per year. And if you're like me, that's kind of shocking. When I read this, they buy 8 tickets, but my brain just kind of goes numb on that fact per week. And it just really focuses on the $3. And that just seems really, really small. But once we loop in the fact that it was 8 tickets per week, really, 52 weeks in a year, this $3 cost, which seems minuscule, no big deal, is starting to turn out to be pretty substantial. That is, again, a pretty big chunk of change. That could be a big car repair that you might have to do. Any questions at all, folks? Getting the 1,248 per year for the tickets? Okay, well, that's the big part of the problem, just doing that conversion there. The next element is the spending $650 per year on textbooks. That's already on an annual basis, so we don't have to do a conversion there. So that's kind of nice. But the question itself, let me just redo the highlighting here. That actually didn't work out. Let me leave it alone. The question was asking, on an annual basis, the money spent on lottery tickets is what percentage of the money spent on textbooks? So let's now address that question. Amount spent on, I'll just say the lottery, is, when it says what percentage of the money spent on textbooks, that's what forms our denominator. So this part right here gets thrown into the denominator as the $650 per year. Then the amount of the money spent on the tickets, that's going to form the numerator. We found that to be $1,248. We want this in terms of a percent, so we'll go times 100%, as we did in chapter 3. And we are expecting a pretty large percent beyond 100%, because we can just see on paper already, this amount is nearly double the $650 spent on textbooks. And that's another way we can tell that we have our fraction right. This should be beyond 100%. So if I got a small percentage, it's possibly because I just flipped a fraction. Okay, so back in the calculator, go 1248, divide by 650 times 100, and we have 192%. So amount spent on the lottery is 192% of the amount spent on textbooks. Again, that deserves an exclamation mark, because even though this was kind of a basic kind of example, you can imagine this could be any simple kind of cost. Maybe it's, say, buying, I have no idea, maybe coffee or buying a candy bar on a habitual, regular basis. Those costs, even though they look small, they absolutely add up in surprising ways. And when we relate it to something else that we might consider vital, it feels like the math is just not working out for us, and that's a good place to control our spending on. And we're thinking about the larger concept of making a budget. This helps us on making better decisions. Well, again, this unit, taking control of your finances, is a really large scope for that topic. We're just looking at small examples like these as it fits into that overall theme. Any last questions at all, folks, on getting through this percent computation? Okay. Again, some of these examples are a little bit fast. Some of them are slightly tricky. I think the percent problem is pretty tricky, personally, getting the fraction in the right order. So when you're doing these in the MyLab homework system, the order of the problems that you see in MyLab pretty much match the order of the problems you'll see here. You can use these notes as a resource when you are taking a look into the questions that you're coming up with or looking into on MyLab. But now we're changing gears into the next topic, the four-step budget making process. Well, at least our author's four-step process. Other people might have different kinds of advice. Maybe they come up with 12 steps, who knows? But for the sake of making something simple, I think a four-step process is a good idea. It says, step 1, determine your average monthly income. And that makes sense. Making a budget is all just determining how does your inflow, your income, compared to your outflow, your expenses. So knowing your income is really the first thing we have to be really sure about. It says, be sure to include average monthly amount for any income you do not receive monthly, such as once per year payments. As a student, I had to be mindful of this. I was on a pretty limited budget, and I would take, say, a student loan twice a year. And so that wasn't my full income. That was just the supplement part that would happen at irregular intervals, not monthly income. Step 2 says, determine your average monthly expenses. And that might not be too hard, but it's a good exercise just to put down on paper once and for all, what are my payments I have to make on it every single month on a regular basis? For me, it's stuff like the internet payment, gas payments, insurance payments, and it just goes on and on and on. It's quite a long list after when you put it all on paper. But that's not the whole story because there's lots of stuff that can kind of slip through the cracks. And if we miss them, our budget's just going to fail. It's going to collapse. When we try to make a budgeting process, be sure to include an average amount for expenses that do not reoccur monthly. They could be things like, say, county taxes that come up twice a year. If I'm not being mindful of that, and I think I have a lot of money, but suddenly a big payment comes through for county taxes, I could be suddenly realizing I need to rely on the credit cards more because my budget didn't make sense. Other things could be tuition, books, vacations, insurance, holiday gifts. We have to also factor that in. When we take these things and convert them to, say, average monthly amounts, we're not doing anything too different from what we've been doing on these kind of problems. We'll convert things that happen once a year, twice a year, 3 times a year into a monthly rate, like we are doing in these kind of problems. And that will help us see if the budget actually makes sense, if our inflow matches our actual average monthly outflow. So that's step one. Step two, any questions at the moment? Okay, so we'll look into pretty much all steps here. We'll look into step one, looking at the income. Step two, looking at expenses, both as average monthly amounts. Step three, we'll look into cash flow. We'll do that by subtracting expenses from your total income. And this is going to be the big topic that we'll be looking at in the next several examples. So cash flow is defined verbally by subtracting total expenses for your income. I think it looks better on paper if we say cash flow is equal to income. I think income makes sense in green because money, dollar bills are green. Income minus expenses. So we'll look into cash flow computations. Our hope of hopes is once we take all of this into account, including the things that happen at irregular intervals, this comes out as a positive number. And it might just be negative. If it's negative, that's where step four comes into play, make adjustments as needed. Well, usually adjustments are sacrifices. This is going to be the part that we won't do on these notes, but we'll briefly comment on them. We'll focus pretty much on just steps 1 through 3 on the budgeting process. Well, this is our ideas so far. We're going to be using the cash flow as a formula as it comes up in some of the examples down below. But any questions at the moment? Okay, well, examples 4 and examples 5 are kind of warm-up examples altogether, although example 5 looks like it has kind of a lot going on. When we look into the idea of cash flow, that's going to be the examples below, example 6 and example 7. We're going to look into the cash flow to see if they are in a positive or in the negative on either one of these situations. And this is essentially what the upcoming quiz number 5 is going to be about, one of these two different kinds of scenarios. So first, we're building our way towards that on example 4 and example 5. It says for the following situation, find the average monthly expense that you would use in the budgeting for the given expenses. Use in budgeting for the given expenses. So we're told Sarah pays $5,800 for tuition and fees per semester, specifically 2 semesters attending. This will be in addition to $500 for textbooks each semester. We want to know then how much is Sarah going to pay on a monthly basis. So what we'll do is we'll take this amount here, $5,800 for the tuition, plus this amount as well, the $500 for textbooks. These are both for 2 semesters at the same time. So we'll have to double these, say go times 2 on both. And this would be for the 1 year. We want to get this down to the average monthly expense, but this gets us started. For the year, attending 2 semesters, it'll be the tuition cost plus the textbook cost, and the 2 semesters is captured here, multiplying by 2. Then to get to a monthly basis, we'll take this and write for the 1 year, we'll have 12 months. And this is what the unit analysis will look like on this one. This time we're dividing by 12 to get this to the right value. We'll have year and year cancel out here. And this is now essentially the cost of college in terms of just fees, tuition, and textbooks on a monthly basis. So putting this down on paper, we'll have 2 times 5,800 plus 500, divide by 12, and it comes out to a cost of $1,050 exactly, which is quite a lot of money on a monthly basis. But in building the budget, this gets this person started. If we know that this is going to be the average cost, and we don't want to take student loans out or anything like that, our budget has to reflect that this much money is flowing out of our expenses. This is quite a large expense on a month-by-month basis. Any questions at all, folks, on that first example here? Okay, the real usefulness of this number is Sarah can now make really informed decisions. Maybe she's looking into different jobs, but whatever job she might take, the pay per hour of that job has to reflect this real world expense. Or the other decision Sarah might make, like I had to make for quite a few years, is taking student loans to offset this amount and just get by during the years that she's in college. But here's a new scenario. This one seems to have a lot going on, so let's maybe put this on a new page so we can start off fresh on this one. It says for the following situation, find the average monthly expense that you would use in budgeting for the given expenses, round to the near cent as needed. So we're still looking into just expenses on example 5. This one has a lot going on. It says, suppose your monthly expenses, that's nice, this is already in terms of monthly expenses, are $1,200 for rent, $213.16 for minimum payment on a credit card. That kind of implies that that's a large balance on the credit card, but life happens. Sometimes we get behind. $56 for internet, $43 for gas heating. That might not make sense because we're in winter, even though it doesn't always feel like that. But this was assuming on level pay, just means they have given an average amount that they'll pay on the warm months versus the cold months. And this person's paying $43.17 on that level pay. So that's just the average amount for gas heating. $130 on a cell phone plan, $354 for the car payment. That's not too bad since car payments are starting to blow up in this country. And $298 per month on utilities. So let's take all of that and just tally it in. These are nice because there's no conversions we have to make here. These are just bills that you pay on a month-by-month basis. So we'll say here, monthly expenses will be, we'll just go into the calculator and add up all these dollar amounts, making sure we don't miss anything, like say rent, that one's a big bite, $1,200 to start, plus 213.16. Down the line, we're on to internet, $56, plus 43.17. Level pay is kind of nice because it gives us some stability on our month-by-month finances. $130 for the cell phone, $354 for the car payment, and $200.98 for monthly utilities. And you can imagine there's a lot of stuff missing here, right? There was never anything mentioned, say, what's the car insurance bill, other things like you might be able to come up with. We'll just assume maybe this person is married and the spouse handles the other expenses. So this person is just on the hook for those amounts. And it comes to kind of an eye-watering $2,197.31 per month. 219731. So you can imagine this is a pretty realistic looking situation. These expenses are pretty high, especially rent. Some people might have roommates where rent is split, and that can drop it by quite a lot. The credit card payment is a pretty high one as well. That's a minimum payment. So once again, that's a pretty high balance if that's a minimum payment. But if they're doing the first step of making a budget, you have to know what your expenses are. And this is what it looks like so far. But it's not the whole story, right? If we just look at the monthly expenses we have on a typical month, but we ignore things like the homeowner's insurance that's paid annually, property tax paid semi-annually, oh, and auto insurance is here, 635 semi-annually, then this is not the whole story. We have to include these in our monthly expenses as well. So this is the next level we're going to analyze. Let's put all these in green and convert them over. So let's go down the line. It starts off with 1,800 annually for homeowners. So we'll convert that to monthly. So I'll just call this home insurance for short. $1,800. If this was in California, you can imagine that this is possibly 10 times that amount, or maybe Florida. But for Idaho, that's not too bad, 1,800 for a year. But this is, again, per year when it says annually. So that implies 1,800 per year. To get it to a monthly expense, we'll go times the 1 year, divide by 12 months. And this is going to be rolled into the monthly expenses we have here to determine the actual amount for all expenses together. So take 1,800, divide by 12. We get $1.50 per month is the cost for the homeowner's insurance. And you might ask yourself, why isn't the homeowner insurance just being billed on a monthly by month basis? Well, it's up to the person paying this bill. If they just pay the policy every time it gets renewed on the yearly basis, they're possibly more likely than not actually saving some money. So a lot of homeowners insurance or even auto insurance are going to charge you, say, like a $5 or more service fee if you break this up into a monthly payment. So this being made as a real monthly payment is going to be more than 150 per month. This person is just making the judgment call to save on that service fee and paying the full amount when it renews annually. But if they're actually going to pull that up, they have to look at the average cost, roll that into their budget so that they know that they have the money set aside to afford that bill. So that's one down, homeowners insurance. Any questions at all, folks, on that rate there? Okay, this question, or this part of the question, I feel like I didn't write it the best way. If this was an exam question, I would say in parentheses exactly what I mean by semi-annually. But any volunteers for what this would mean? What is 775 semi-annually actually implying? Anyone happen to know?
You pay it twice a year.
Yeah, exactly. Semi-annually means 2 payments per year. So let's put that in here. Again, if this was an exam question, even if you know that, the stress of an exam can kind of jog that memory loose and we might forget. So I'll absolutely say on the exam on paper, twice a year, just as a reminder. I think I said that in other places on the notes. I just forgot on this spot. So if this is $775 two times per year, we can say that property taxes, I'll just abbreviate to taxes, are going to come out to 2 times $775 per year. So that's the semi-annually in action, the times 2 that you see right here. Then same conversion as before, take a year, divide by 12 months. And now we know the monthly rate that's going to be rolled into the expenses portion of this budget. We just need to put it in the calculator once again. So let me drag this up here. So we have 2 times 775 divide by 12. It's because it's money, we'll assume that we're going to round all these to the very nearest cent, and the same statement would be made in the MyLab exercises. So this one comes out to $129.17 on a monthly basis. And then semi-annually again on auto insurance, we'll do the same kind of computation, just a different number right here. So I'll say car insurance for short. It's going to come out to, it's semi-annually, so again, twice a year, 2 times 635 per year, then multiply by the conversion factor, 1 year over 12 months. But in the calculator, pretty much it's sort of set up. We just are changing the 775 to the 635. So slightly less, $105.83. And that takes into account all of the random expenses that happen on not a monthly basis, different intervals, annually or semi-annually. If it's quarterly, I'll mention on the paper 4 times a year, that could be another possibility. But now, if this person is finally going to make a budget, they need to know their income. We're just looking at the expenses side. But we can say the total expenses are going to come out to the 219 or 2197.31 per month. Then add in these 3 random other expenses that show up. This one is also per month, plus the 150 per month for home insurance, plus 129.17 per month for the taxes, plus $105.83 per month on car insurance. So things get expensive. This is adding up pretty quickly. But now we can see if this person can afford everything or if difficult choices and sacrifices have to be made. So let's tally all this together. 2197.31 plus 150 plus 129.17 plus 105.83 comes out to an total expense $2582.31. So we did it, folks. That's the total expenses for this person. It's quite a lot, but you can imagine that this could be pretty practical. If this was, say, a teacher that works 9 months out of the year, they might need to now make a determination. I can pay my monthly expenses just fine with my salary, but these ones are going to put me in the negatives. My income is too low. It looks like I have to work over the summer. Doing this computation is just going to inform what we have to do next. Or we might find that we can afford that, we're getting paid enough. We're just going to make sure that the homeowner's insurance doesn't get too costly on a year-by-year basis. Otherwise, we'll have to make difficult decisions on our budgeting process. Well, on the next examples, we're going to look at the total flow of money, income minus expenses. We're just looking at the expenses side of it so far in the notes. Well, it looks like we are running out of time as well, but any last questions at all, folks, doing any of these computations? Okay, next class, when we come back Thursday, we'll look at the actual flow of money, income minus expenses in these different kinds of random looking scenarios. Then we'll turn to the kind of tougher part of the notes, decision-making processes, comparing costs on different kinds of things. But thanks for your hard work today, folks. We'll be back to this when we come back on Thursday. Same kind of stuff. Have a great night, and I'll see you all next time.